Hey, welcome to Civil Tech. I hope you will enjoy this video. Please don't forget to subscribe and share. Also like, please. Let's start. So hello guys, today I am coming with another different videos. Today's video is about MD method, moment distribution method. So in this method, here is also 5 steps. Main 3 step is calculation only 2 step, and another is diagram, then BMD SFD. Is very easy, but we have to clear here concept now. Remaining step formulation are all are similar to first 2 method. What is the method like the similar, but here only 2 or 3 steps are different, so we'll see here. Okay, here also same beam and frame, fixed, continuous, overhanging, frame sway, non-sway, both are similar. So come to here, see here a numerical. This is our first step, our numerical. First step is similar. Okay, so before starting I'm showing you something different here. First step or FEMs, final fixed in moment. It is as it is of the SD method. So second step is stiffness factor or distribution factor. Stiffness factor, what is stiffness factor? Stiffness factor means what? Deformation per unit load. You understand? Suppose example here, this is a beam. At a certain distance, how much deformation is occurring in this beam? This is called stiffness. Okay, so suppose here A, B, C. Because of some load, considering here external load here, how much deformation is occurring on this position only. This is called stiffness. Stiffness at point B is point AB. Okay, this is stiffness or distribution factor, both are same. Next step is MD table. MD table is fixed in all numericals. It will be similar. Here the concept is little bit different, so we'll clear also. And then other one is bending moment diagram, then SFD shear force diagram. Okay, so here see here, this our figure. One end fixed, another end is hinge. Okay, there is different load, different values, different to AI, 2I, moment of inertia, single I. So first step, calculation FEMs. We know this, right? How to calculate the FEMs, right? We learn it in the first videos. I've explained in details in the first videos how to find this, how to get this formula for why we are applying this. I've already given this all formulas now. So I'm again repeat telling here, minus PAB square. Why this? Because of the moment here in anti-clockwise. That's why we are applying minus MFAV for MFAB. No, this is because AB square, because of this different distance. No, the point load are situating the different distance from on either side. That's why we are applying this formula. If there will be similar distance, suppose 2 or 3, then it will be PL by 8, right? That's why for UDL it will be WLE square by 2L, right? We know that. So similarly here, we're getting this value minus 22.5 kilonewton per meter. Similarly here 7.2. we're getting this just by using formula. No, for span BC also 3 meter A and B. getting this value. Just next step, step 2, calculation distribution factor stiffness. This is our table. You have to remember the table. Okay, first one serial number. Next joint. Here only one joint is there. This is also two joint, but it is fixed end, so that's why we will taking at 0. Will not considering this point, only that points only. BA and BC will finding BA and BC, then we will getting the value at rotation at point this point. Okay, distribution factor. So see here for point B, BA, that means the side, and BC, this side, so BC. Next one is stiffness. How much is this stiffness? There here 2i, no, that's why here 2, right? And next one is I, single I, this way is 1. Next, relative stiffness. What is this relative stiffness? This is the most important concept here. See here, relative stiffness means the stiffness capturing by the load, on the portion on the beam. How do we assuming if there is the fixed end? Suppose this is B point, this is AB, this is C, both are fixed, and this is point, the hinge. If we taking on this side VA, it will be I by L. The stiffness will be I by L, only I by L. This is fixed in, because of this fixed in, it will be directly will taking H I by L. This side also BC stiffness for VC, just I'm here giving example. Okay, just try to understand. That's the side also will be I by L. This is length L, and assuming stiffness I because of the fixed in. Next example, if there is the free hinge, okay, not free hinge, this is simply supported, okay, not fixed, A, B, C. It will be how much? L distance. It will be 3i by L, 3i by L, BC, okay, BA equal to 3i by L, because there is not fixed in, there is the free hinge or extra any hinges are supporting, it can be extended further, that's why it is 3i by L. But how do we get this now? These are deriving from the formulas. This is the formulas we're getting. But you have to remember, just if there is the fixed end, you will taking as I by L, and if there is the free hinge, it will be 3i by L. Suppose another, okay, another line is there or fixed or whatever. For that's it with respect to B. If you're taking BC, no, BC, it will be also I by L, I by L only, because it's free, yeah, but after that there is the fixed end or extending with a further line, this way. Just only 3i by L will be when whose time? This is the last ending with the free hinge or simply support or without fixed end, that time only will be 3i by L. Okay, this is the main concept. I hope you will understand. Next is that. So here, see here, because of fixed, our stiffness at point VA 2, that's stiffness, this formulas 2, and single, this is our, once again, this is I by L. Okay, the next calculation 2i by L, 2 means that is already given stiffness, we are taking this stiffness here 2 2i by L equal to, it will be I by 4, right? For VC, for this one BC, BC 3 by 4, 3 by 4 means 3 by yes, 3 by L. Oh yeah, 3 by 4 into L. I'm not giving one thing here. 3I by 4L. This is 3I by 4L. Okay, so 3 by 4I by L, that means 3I by 4L. It will automatically, it will be 3I by 12. How do you get 12? L equal to here given 3 meters, so it will 12 now. Then lastly, total relative stiffness. In that point, we will taking the LCM of this BA and BC. If we are taking LCM of this, we will getting this 3I by 4. The next time, our distribution factor is this relative stiffness by total relative stiffness. Okay, we will calculating this, we will getting this value 2 by 3, and here 1 by 3. Just remember this portion and see. Then step 2 complete. This is most important. And remaining calculation, this is not necessary, this is just useless. Left this out. Lastly, we will coming directly to the step 3. This is our step 3, means diagram. Directly we will coming to the diagram. So in the diagram, I'm saying here something. In diagram C, two types of diagram. One fixed on both sides, and other is with 1 inch with free hinge, or simply supported or hinging, whatever. No, with fixed both end and one simply support or hinge. If there is the fixed end on both sides, we should not take carryover moment. What is carryover moment? Carryover moment means taking half values of the moment. Suppose this is pain here, this ABC. Now this is free, simply supported on the last end, not fixed. That's why taking carryover means half values, negative, opposite half values. How much is this? 13.3, you know. So opposite of this minus 13. So it will, if you take half values of this, it will be 6.66. Direct adding on this point. Okay, this already we're getting here. So figure ABC distribution factor, whatever we're finding here, distribution factor 2 by 3, 1 by 3, we're putting here at point B. For V and BC we're finding it now this way. Next one, FEM's value, fixed in moment, where we're getting these values, just this one putting on this point, FEM's. Okay, lastly, because of this this is simply supported, you're taking carryover moment. This is carryover moment at this point. Then because of the taking carryover moment, now we have to draw double line here. This indication we're taking carryover moment, double line. If you take a double line, that means this indicate you taking carryover moment. Then calculate this subtract or adding, whatever. So this is our as it is value, this as it is. Here will be changing, minus plus 13, value will be same, minus 13.3. this 0, we taking this value as this side, that point, so it will be directly 0. There will be not any calculation extra. Okay, value taking carryover either this side or this side. After taking carryover, there will be not any calculation. Okay, just remember it. Next step, this is our final value. Now we will calculating how to calculate this. Remember, if there is negative values, okay, if there is negative values while you calculating in calci or directly, you should assuming as positive. Your negative now will assume as a positive, and every here positive will taking as negative. So see here what the values we're getting now. How much? Plus 7 now we're taking, this is minus 13 now we're taking plus 13.33 minus, it will be minus 7.5. okay, this is our first calculation into, for that's Spain BAB will taking this distribution factor value while calculating that side, we'll taking this only. 2 and 3 2 by 3 how much? 3.8, that means 3.89 approximately. This see here exact values come here. So while you calculating that side value, we'll only adding this only, this point 1 by 3 now, just add here 1, here 1.98 exact value is coming here. Okay, next value, this 0 will not calculate on the side anymore, so next on this side only. So whatever will value getting here, we're just taking dividing by 2 for balancing this. This is our rule. Whatever gap values we'll finding here, it will be divided by 2 for next step. So if you divide by 2, how much? 1.945. So just bring this value to here, that's line. Okay, next there is no more any calculation. Okay, if there will be any step difference, suppose extra line is there, it will be calculation longer little bit. So this is our last final value. Now calculation, leave this, will not calculating in these values because we already taking as here the final value. No, this is, so we'll just including this one and this for final moment at point B, at point A. This and this calculation after calculating we get minus 20.55 for this 7.5, 3.89, getting 11.39. This is minus 11 and this will be 0, taking carry over. This is our final moment. Okay, this is our final moment. MAB, MBA, MBC, MCB 0. Next step is same calculation for span moment for drawing BMD. No, this all are same. For free diagram, for free bending diagram, we have the equation of this. You already know this, no? Because of the different values of this span, we are calculating this value as PAB by L. This is our formula. If there will be similar value, it will be PL by 4 for final load, and WL square by 8 for UDL. Remember, similarly we getting this value. This is to drawing this diagram, we calculating here with the help of loads, and the different sides of the distance. So PAB by L, we're getting 30 PAB by for span BC. PAB, P means how much? There 30 into A means 2, B means 1. So 2 into 1 by L means 3, 30, 20. So this is do you think how to draw this figure now? Already learned this now. 20 because minus 20. See here, this is our original figure. Minus 20.5 spin A B C. No, minus 20.5. This is 11 positive, that's why it's clockwise. 39 minus 11.39, this is 0. No, not right, because of this it anti-clockwise and not anti-clockwise, it is hitting upward side now, that's why it going up. 20 11 0, just connect it. Good penny moment diagram. Next step, calculation for SFD. SFD, as it is, we know that how to calculate SFD reaction taking moment at point B, while finding the reaction at point RA here, then taking moment about point C. Okay, while finding to evaluate reaction B, then taking vertical moment, summation of V equal to 0, or A or B or C equal to this, or logged, we're getting the reaction at C. Then as safety, we're finding a reaction RA at point there 32. It's going upward because of this 40 kilonewton. It will join here and coming downward. 40 minus 32 equal to how much? 7.9. It will be coming till this point. Okay, connect here. Then it will be going upward at point B. How much we getting? B 21.5. 21.5 at B point now. So 21.5 minus 7, how much? 13.8. Next it will be coming till that point 30 minus this, how much? Remaining value 16.2. just join this. Next, this is assembly. An elastic curve is as it is, we know it's very simple. There is, because of fixed, it will be not bended at that corner. After some effort it will bending, then at the fixed it is free hinge. That's why it connect direct bend to the point. Yeah, so today's concept is clear in here. Today just there is not only how much difference is there, only BMD concept. I hope you understand it. And shear force, SFD, BMD all are similar to this first SFD SD method. And another here is stiffness or distribution factor is also different. I hope you understand it. This calculation, just concentrate carefully, you will understand it. Okay, similar type of numericals if you want, I'll providing on the website given below. On the description link you can just visit and you can practice on this numerical. These numericals all are similar, you can practice. Okay, so similarly in case of frame, no, we're doing this as beam, no, for beam. Now for frame also similar, but fusion in some cases. So see here, frame like this. These are frame with both in fixed, two end fixed and one end is overhanging with carrying moment. No, see figure. This is, so all calculation will be same. FEM's calculation similar. You join calculation for the distribution factor or stiffness always similar. Again I'm showing here. See here, for span BA at point J, at point B, at point V, there is BA and BC. There is no support. This is moment. We're taking directly as carryover moment, different values. We're not calculating any BC, BD like that. Not calculating because there is no support any. This is overhanging, free hinge. We're taking directly moment. Okay. Yeah. This is UDL, no? Single I fixed in. This is fixed in. Because of the fixed in, you're taking as I by L. Taking as I by L. And this is because of the it is fixed in I by L. Okay. Then I by L will getting this value I by 4. Then total rotation stiffness. Total relative stiffness. This is relative stiffness. This is total relative stiffness. Total relative stiffness. We're taking LCM of these two. Then we're getting this. After taking LCM, we're getting this value. How to get I by 4 plus I by 3. How much this? This will be 3 on upper side. Downside 3 over 12. Upper side 3i. 3i plus this is 4i equal to 7i by 12. Get it? Now distribution factor is relative factor, relative stiffness by total relative stiffness. We're getting 3 by 7. This 4 by 7. Next come to this figure. So in this figure, this is the most important things to understand how to put this value and how to calculate it. Okay, first, according to this figure, what is our figure? This is our figure, right? Load here 10 kilonewton, this is 2.4, and this is fixed end C. This is here load extra 12 kilonewton, 3 meter high, this is 4 meter high, 1.5 meter. No, this is our figure C. How to draw this figure, or in case of frame, BMD method. Now this is fixed, we'll draw a box here. This remaining end will not draw any box, this is just as it is. See here, this will be also like this. So this is moment, because of this moment at point A, B, C, D. With respect to point B, we will be taking moment 10 into 1.5. How much? 10 into 1.5 equal to 15. Okay, this is clockwise rotation at point D. But if we are taking at point B, this will be opposite of this. Here this is positive. No, this is positive, it will be negative values. 15 minus 15. Okay, this is B. We'll put in the distribution values. What we're getting here, distribution values 3 by 7, 4 by 7. Put in here. This is been AB. How much? 3 by 7. B by BA, no, 3 by 7, and BD. How much? Not BD. This is BC. 4 by 7. Okay. This not, we're not calculating here, this overhanging, so leave this portion. Now see in this figure, after taking this value, we're putting this FEMs. We're calculating here FEMs value. So it's an AV. So for a spin AB minus 3.7, minus 3.2. For a spin AB minus 3.2, this is 3.2, this is 3.2, positive, negative, we put in here. Then 4.5, 4.5, MBC, MFVC, and MFCV. How much? MFCV 4.5 also, 4 point plus. MFCV 4.5. Okay. Oh, it is disturbing. Sorry. Remaining because it will be as it is. So here, see how to considering this value while calculating this in this figure. Our formula is for distribution factor, sum of the FEMs at joint, connecting at the joint. Sum of the FEMs means this FEMs. This is our FEMs now. Here one FEMs. This is also one FEMs. Our first FEMs is this. No? So this is our formula. Rotation moment. We're finding a rotation moment. This is our rotation moment. Distribution factor into sum of the FEMs at joint, okay, plus sum of the far end rotation moment meeting at the joint. That means if there will be extending any extra span, there will be some value, it will be added to this position. But now this ending with this point only, that's why we will not taking this, only calculating with this point near end plus far end, rotation moment into near end plus far end. Okay, here rotation moment is 15, 4.5, 3.2. we will calculating, adding this and then multiplying with the distribution factor, then we'll getting this value. See here, 3.2 minus minus 3.2, it will be positive, it will be negative. No, this is negative value will be positive, minus 4.5, then minus 15, no, it will be plus 15 into distribution factor was 4/7. How much is this value? Oh, sorry, here negative value, I have to take in positive. No, I should take it positive. See, 9.314 exactly come now, 9.3. Similarly for that is fine, we're taking this is why here we're taking 4/7. Now here we're taking 3/7. While taking 3/7, the value will become 6.98. See here, 6.98. This is our all adding near FEMs. Okay, near joint of the FEMs into distribution factor. After calculating this, what we getting FEMs, then it will be taking as carryover for the next span. Fixed in moment, there will be calculating little bit rotation will be here. Because of this, we'll taking half of this value. This is 9.3, we'll taking half. How much? This 4.65. Here also 6.9, half. How much? 3.49. Okay, then calculating with the last values, there will not be any calculation because it is ending with this only. Next calculation, if you calculate the next value, it will be the similar value because this is not extra ending supporting on the beam on its spine. No, that's why it will be as it is. So we'll in concluding here, no, not including any extra values. So we're just adding this value, we're getting the final moment. This is our final moment. This is our final moment. This is the concept. That's it. Now through this we can draw bending moment as empty elastic curve. This also similar to like that. So it's okay. This is the concept of frame. Here the changing is there. Calculation for MD table. In case of frame, there is little different. No, and remaining things all are rest are equal, same. So okay, I hope you understand it now. Understand? Okay. Bye. Have a good day. And if you want the similar type of numericals for your factors, you can visit the given below description link and enjoy this. Okay.